So in today's lesson, we're going to talk about electron configuration. So before you get started, I want you to take a moment. I want you to think in your head of a periodic table, or look at one in your notebook that we've been working on, and look at the whole periodic table as if it was a town. So this is like the city of Charlotte. What you're going to do is think of each element block, so the hydrogen block, the sodium block, the oxygen block, as a building. Okay. If I tell you to go to a certain building, if I told you that I needed you to go to the Duke building in Uptown, what do you need? Well, you need an address. Okay. You need an address. Just like, so every element is going to have its own unique address. And that's what we're looking at today with electron configurations. So electron configurations, they are addresses. They're representing the way the electron is arranged on the atom. So in our Bohr model, what we saw was that that electrons go into specific rings. Okay. In the quantum model, they're in orbitals, but we know that only certain things can hold, only certain rings or certain orbitals can hold certain numbers. Okay. So we're going to look at how this is then played out in writing. So electrons enter the lowest energy level first, right? Because you always want to start with low energy and move up. Think about when you work out, you always want to warm up first. So you're going to start with your low energy first. And so we're going to start with our energy level 1, and we're always going to start with our s orbital. So we're going to do 1s, okay, 1s, and we're going to move from there. So each row and orbital section you go through needs to be recorded, just like you would give a specific direction when you're navigating to someone's house or to a specific building, right? If you put into GPS, it'll say, in a quarter mile, turn left onto Albemarle Road, or Route 21, or merge onto 77, okay? Those are specific directions. You're going to do the same thing. The big number in the front will tell you the row it is in. Okay, remember, those are periods. So if you have the number 3, it is in row 3. Okay, there are some exceptions we're going to talk about, but know that the big number is usually where you're looking. The letter tells you the block you went through. Okay, so remember, there are 4 blocks. There's S, P, D, and F. So that letter tells you you're going through that block. And then the little number that is a superscript, that means it's above, okay, like Superman flies above the planet, okay, that number tells you how many blocks you go through or land on. So just like if you're playing a board game and you rolled a 6, in Monopoly you move 6 blocks, here's the same thing. If you have a 6, you're moving 6 blocks, and that 6th block is where you're landing. So we're going to look at the configuration of oxygen. So we're going to start in the top left corner, and we're going to add each row and each block we go through until we get to oxygen. Okay, so starting here, we're in row 1. This block is the S block, and remember, helium really belongs over here. So I'm going to go through 2. So 1s2. That was what I write first. Okay, and then since I've come to this, I have to go to the other side. I'm going to come back. Okay, it's like turning left. And now I'm in row 2. The first block I'm going to go through is S, and I'm going to go through both of these blocks because I'm nowhere near oxygen. So it's again 2s2. All right. Now I'm going to come across. I have a big gap, but I'm going to come over here. I'm still in row 2 though. Okay, I'm still in row 2, but I'm in a new block. I'm now in the P block, and then I'm going to count how many blocks I'm going to go until I land in oxygen. So 1, 2, 3, 4. So then I would write 2p4. That is the electron configuration for oxygen. Okay, to check I did it correctly, I'm going to add all the subscripts, which is those small numbers, together. That's the number of electrons. Remember, our number of electrons now, because we're still dealing with neutral atoms, is going to match our atomic number, the number of protons. If it does, you're correct. If it doesn't, we have to recheck our configuration. Somewhere we went wrong. Okay, we might have forgotten to put down a block or something like that. So again, my configuration is 1s2, 2s2, 2p4. So 2 plus 2 is 4, plus 4 is 8. My atomic number is 8, and I match. So 8 electrons does equal oxygen. Okay? All right, let's try another one. Let's try silicon. Okay? Again, we're going to start in that top left corner. So I have row 1. I go through the S block, and again, that helium really should be over here. And so I go through 2 blocks, and it's 1s2. I'm going to come down to my next row. I'm going to have row 2. My first block is S, and I go through 2 of them because that'll take me to BE, and that's nowhere close to the silicon that I need. I'm going to come across my giant chasm, okay? And here, I'm going to hit, again, I'm still in row 2, but now I've hit the P block. And I'm going to see how many ones I go through. 1, 2, 3, 4, 5, 6 takes me to neon. I'm still not at silicon, so I need to continue on. But I'm going to write down the fact that I went through the P block. And so I'm going to put 2p6. Okay, so this takes me to neon. Okay, now I'm going to go to my third row. Again, I'm starting with that S block. Okay, and I go through, and that takes me through magnesium. So I'm going to write 3s2. Again, I'm going to go across this giant chasm. Okay, and then 1, 2, so 3p2. And again, I'm going to be able to check that by adding them up. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 2 is 14, and then 14 equals the number, the atomic number. Okay, so 14 electrons equals the atomic number. I am correct. I'm in the right configuration. Okay, writing electron configuration for the d orbitals and the f orbitals is a little different because those levels are going to go inside. So the biggest thing with an electron is to be happy, it needs 8 electrons on the outside. The exceptions are helium, hydrogen, and boron. Okay, we talked about those before. Those helium and hydrogen just need 2 in their outer shell because that's the most that first shell can hold. And then boron is just special. It only really wants 3 in its outermost shell. But for the most part, everybody else wants 8. Okay, and because everybody else wants 8 to be stable, when we get to the D and the F block, they're going to go into previous rings. So for the D orbital, the transition block, you're going to do row -1. So if you're in row 4, you're actually going to write the number 3 in front of your letter. If you're in row 6, you would write 5 in front of your letter when you write the configuration. Okay? So if I was doing iron, I would go through 1s2, takes me to helium, 2s2 takes me to beryllium, Be, 2d6 takes me to neon, Ne, 3s2 takes me to magnesium, 3p6 takes me to argon, Ar, okay, 4s2 takes me through calcium, and then 3d6, remember that third, even though I'm in the 4th row, those electrons in the transition metals are going to go into that 3rd energy level, and then I count over 6 blocks, and that takes me to iron. Okay, the same thing with the f orbitals. The only difference is the f orbitals, those lanthanides and actinides, they're going to go into do row -2 because really they're going to fit into rows 5 and 6. I'm sorry, 6 and 7, and so they're going to be row -2. Okay, so go ahead and then you're going to move on to your lab where you're going to work on that and talk about more of electron configuration.